Okay guys, so here's the explanation video for the problem that we did in class today. How many grams of sodium azide would be required to provide 75 liters of nitrogen gas at a certain temperature and pressure? And we've got our balanced chemical equation. So the first thing that I would do when I would go about solving this problem is basically rewriting all the information for the question down. I've got my balanced chemical equation, I've got the end goal, and I put a box around that just to remind myself that's what I'm looking for. I've also written down the volume of nitrogen and the temperature and pressure that nitrogen is under. So then we sort of have to come up with a plan of attack, a way in which we're going to solve this problem. I might write out a strategy. So number one, find moles of N2. Number two, use that number of moles of N2 to find the moles of sodium azide. And then number three, just convert from moles to grams. So find grams of sodium azide. That's going to be my three-step process that I'm going to go through. So in order to find the number of moles of N2, well, I know that it's a gas, so N2 gas. I'm given a volume, a temperature, and a pressure. So in my mind, I'm thinking, well, I can probably apply PV equals nRT, the ideal gas law. And if I just plug in those pressures, temperatures, and volumes, I can solve for the number of moles. So 0.984, again, remembering that I need to use atmospheres here, so I've converted millimeters of mercury to atmospheres. My volume of 75.0 liters. That's going to equal N, which is my unknown. R value 0.08206. And then my temperature in Kelvin. So again, a really common mistake that people make is putting in Celsius here instead of Kelvin. So just plugging that into my calculator, I can solve, and that will give me N equals 3.02 moles of N2 under these conditions. So again, once I come to this value, I want to say to myself, what does this represent? What does this mean? 3.02 moles of N2. That's going to be the number of moles that would take up the 75 liters of space under these pressure and temperature conditions. So that's step one, find moles of N2. Step two, I'm going to convert that moles of N2 into moles of sodium azide. So I'm just going to use the mole to mole ratio. So if I just say multiplied by 6 moles of sodium azide for every 9 moles of N2, my moles of N2 will cancel out. That will leave me with 2.01 moles of sodium azide. So that's step two in my strategy. And then the last step, find the grams of sodium azide, which is, again, right, referring back to what I'm looking for here, which is my final answer. So then just to do that, 2.01 moles NaN3 times 65.02 grams for every 1 mole. And this, again, I just calculated based off 1 sodium and the mass of 3 nitrogen atoms. Add all that together, you should get 65.02. And that gives me 130.8 grams. Now, I want to use the correct number of sig figs, so I'm going to round that 130.8 to 131 grams of sodium azide. And that is my final answer. So again, once you get to this point, right, as I've been saying in class, now's where you want to be able to follow your work all the way through, so you can say, yes, I understand all the steps, why I'm doing each step here, how it relates to my strategy, how that gets me to my final answer, 4 grams of sodium azide, and be able to explain all of this. You should also really work on writing everything out so it's really easy to follow. I think all of this work that we see here, you can easily follow along, where I'm getting this information, how I'm applying PV equals nRT, what these values represent. So that is the first video of many to come. If you have any requests for videos, feel free to let me know, and I will post them shortly. Thanks.